Ever wonder why a giant fabric balloon can lift people into the sky with nothing but fire and a basket? It sounds like a recipe for a disaster, but it's actually physics. Today, we're floating into the sky, literally, to uncover the surprisingly brilliant science behind hot air. In 1783, two French brothers, Joseph and Etienne Montgolfier, were playing with fire, literally. They discovered that paper floated when burned underneath. So in true why-not fashion, they built a massive linen balloon, filled it with smoke, and let it rise. First passengers aboard? A sheep, a duck, and a rooster. Basically, the French version of Noah's Ark. But it worked, and just like that, humans had discovered flight, thanks to fire, fabric, and a little bit of madness. Fast forward to now. The entire balloon works on one elegant truth. Hot air rises. When you heat air, the molecules move faster and spread out, making it less dense than the cooler air outside. Cooler air, being heavier, pushes up on the lighter air. That upward push is called buoyant force. And that's what lifts you, your pilot, your friend who brought way too many snacks into the sky, and the kid who looks like he's gonna puke any time now. Let's dig into the anatomy of hot air balloon for a sec. A hot air balloon is made of three main parts. One, the envelope. That's the big, colorful balloon on top, made of heat-resistant nylon. It can be taller than a 10-story building. When you look up at a hot air balloon, you might just see a big, colorful envelope, but there's some serious engineering going on. So, why nylon? First off, nylon is super lightweight. This is crucial because the less weight the balloon has to lift, the better it can float. Even though it's light, nylon is incredibly strong, able to hold the enormous pressure created by hot air pushing outward. You might be wondering, doesn't nylon melt? Normally, yes, but not on a hot air balloon. The fabric is coated with materials like polyurethane or silicone that protect it from heat. That way, it can easily handle the temperature inside the balloon, usually around 120 degrees Celsius or 250 degrees Fahrenheit. Nylon is woven very tightly and then coated, which means it holds hot air in much better. Keeping all that heated air inside is what keeps the balloon up in the sky. And here's the bonus. Nylon is super-duper flexible. It folds up into a small bag after each flight but stays tough through hundreds of inflations and deflations. That's why most balloons can last for years if well cared for. In short, nylon's lightweight, heat-resistant, airtight, and super durable. That's why you see it on virtually every hot air balloon up there. 2. The burner. A hot air balloon doesn't have an engine in the traditional sense, no pistons, no turbines, no fuel injectors designed by rocket scientists. Instead, it runs on fire and propane. The burner is the heart of the balloon's lift system, a powerful propane-fueled flame that shoots hot air into the envelope. Think of it like a giant campfire, with altitude issues. Here's how it works. It's mounted on a metal frame above the basket, angled directly into the mouth of the envelope. When activated, the flame can shoot up to 8 feet long, with temperatures soaring past 3,000 degrees Fahrenheit. The system runs on liquid propane, stored in high-pressure stainless steel tanks safely secured inside the basket. It includes a pilot light and a quick-release valve, giving the pilot control over how much and how fast heat is delivered into the envelope. But here's the smart part. Burner systems are built with redundancy in mind. Larger commercial balloons often have dual or even quad burners, so if one fails mid-flight, the others take over seamlessly. Because when your only way to stay in the air is a flame, you want a backup plan. The burn is loud, like a dragon clearing its throat, but it's the only propulsion you get. More heat, it's more lift. And 3, the basket. Yes, it's made of wicker. Yes, it looks like something Little Red Riding Hood might carry, but don't be fooled. This basket is a high-performance aircraft compartment. Wicker is chosen because it's lightweight, shock-absorbing, and flexible, perfect for landing on uneven terrain. Inside the weave, you'll often find reinforced steel or aluminum frames along with marine plywood floors. It's divided into sections, one for passengers, one for fuel tanks, and one for the pilot and controls. Larger commercial baskets have padded sides, grab handles, and sometimes even entry doors for accessibility. Underneath, skid plates protect against rocky landings, and mounting points connect the suspension cables. It's designed to flex, not crack, unlike rigid materials that could splinter on impact. 4. The rigging. What keeps it together? Everything is held together by stainless steel cables and carabiners. These run from the burner frame and basket up into the envelope's load tapes. Each connection point is stress tested. In fact, most systems are certified to handle 5 to 10 times the balloon's max load. Pilots inspect rigging before every flight. Fraying, corrosion, or cable tension issues could spell disaster, so maintenance is strict and frequent. Now, the instruments and safety gear. Though it may look rustic, a balloon is still an aircraft, and it carries essential instruments. Altimeter measures altitude. Variometer tracks rate of ascent or descent. Thermometer measures internal envelope temperature. You don't want to overheat the fabric. Compass and GPS for navigation and landing coordination. Two-way radio to communicate with chase crews or nearby airports. Pilots are trained to manage propane flow, burner ignition, venting, and emergency procedures, like quick descents or avoiding power lines. And yes, there's usually a fire extinguisher on board, just in case your flying flamethrower gets a little too enthusiastic. So while it may look quaint and old-fashioned, the anatomy of a hot air balloon is closer to a certified flying machine than a backyard DIY project. Everything is engineered, tested, and FAA inspected, because once you're in the sky, your only ride back down is the one you brought with you. Building a hot air balloon isn't a casual weekend project. It's a mix of engineering precision, safety regulations, and artisan-level sewing. Let's walk through the real process, from fabric to flight. Step 1. Designing the envelope. The process begins in a design studio, not a garage, with aerospace-grade software. Engineers first calculate the desired lift capacity. How many people will the balloon carry? How high should it go? How much propane will it burn per hour? From there, they determine the volume of the envelope, typically between 77,000 to 300,000 cubic feet for commercial use. That's enough to fit multiple school buses inside. The envelope is made from ripstop nylon or polyester, chosen for its lightweight, high tensile strength, resistance to heat and UV damage. The fabric is coated with polyurethane to make it airtight and moisture-resistant. Then it's dyed in bold, high-visibility colors. Not just for beauty, balloons must be seen by aircraft. Designs are laid out in panels called gores, long, tapered strips shaped like pizza slices. Each panel is carefully laser cut. Step 2. Stitching and reinforcing the envelope. Panels are stitched with double or triple row seams using heat-resistant thread. Strong load tapes, webbing straps, run vertically through the balloon to distribute weight evenly from the burner to the basket. At the top, a parachute valve is sewn in. This is a circular vent that the pilot can open via a rope to release hot air during descent. It's held closed by internal pressure during flight, simple yet critical. Total stitching? Easily over 5,000 feet of seams. Step 3. Building the burner assembly. Now the heat. The burner is the engine of the balloon, and it's custom built. Manufacturers use stainless steel tubing, brass fittings, and high-efficiency fuel injectors. Each burner connects to liquid propane tanks using aviation-grade hoses. Includes ignition systems, typically a pilot light or piezo spark igniter. Must pass flame height and fuel flow tests, ensuring it can produce a stable flame at altitude, even in freezing temperatures. The burner frame is designed to attach securely to the balloon's rigging system and includes controls the pilot can operate with gloves. Step 4. Constructing the basket. Wicker isn't just charming, it's functional. Traditional baskets are hand-woven from rattan or cane, materials that flex on impact, helping cushion landings. Lined with marine plywood flooring and reinforced steel frames inside the weave. Designed with compartments for propane tanks, fire extinguishers, instruments, And yes, a step-in door for accessibility. Larger commercial baskets include padded walls, shock-absorbing skid plates, and fire-resistant liners. Each basket is rigged with stainless steel suspension cables that connect directly to the envelope load tapes through carabiners and quick-release systems. Step 5. Testing and certification. Before any passenger steps inside, everything is tested. The envelope is inflated on the ground to check for leaks, seam tension, and vent performance. Burners undergo flow rate testing, and tanks are pressure tested to aviation standards. Baskets are drop tested and inspected for wear. Each balloon must meet FAA, or International Aviation Authority, standards. It's officially registered and given a unique N number, just like an airplane. Pilots must undergo training, pass written exams, and log flight hours before earning a balloon pilot certificate. So, no, it's not just a pretty bag and a matchstick. It's a certified aircraft, painstakingly engineered for one job: floating safely above the world. The result? A certified flying machine made almost entirely by hand. Hot air balloons aren't just tourist traps. They're record breakers, scientific tools, and even escape vehicles. In 1979, two families in East Germany built a homemade hot air balloon and used it to escape across the Berlin Wall. They made it. Balloons have reached over 69,000 feet, flown over oceans, and lifted up to 50 passengers in a single flight. And then there's the Albuquerque International Balloon Fiesta, where 500 balloons take off together in the morning sun, like a sky full of jelly beans. Hot air balloons teach us something simple. You don't need to fight the wind. Sometimes it's okay to just rise with it. No motors, no GPS, no chaos. Just physics, propane, and peace. If you enjoyed this, check out our next episode, The Hidden Engineering of Roller Coasters, where speed meets science and gravity takes a wild ride. Don't forget to subscribe and stay curious, because the sky is just the beginning.